Okay, today we're going to be looking at how to add new movement states to my new player controller. I just finished making it, and if you want to learn how to import it, you can look at my previous video. We're going to be adding the slide state. I've tried to make it as easy as possible to add new states, and I've added many features to make it as expandable as possible. Hopefully this can be a great tool to help you make your game. The first thing you're going to want to notice is that in the player and camera prefab under player, the player movement state machine script has a variable state that always reflects the current state of the player. There are a couple other scripts that are on the player that all have to do with movement, but we don't have to know exactly about those quite yet. Now, in the project folder here, we can see that if we go into the player folder, under scripts, we have the camera scripts, which if you want to add new cameras, there are instructions for that in this script and this script. There are a couple general use script. Gravity just applies some gravity to an object. Here we're applying gravity of 37, it looks like. And world gravity is the static gravity for the world, if you want to use that as well. And then track, just easy thing to set the object location to the location of another object. Just kind of a resource script. Then there's our movement scripts. These are what we're actually going to be looking at. So we have the player movement state machine, we have the AWSD movement, the movement resources, which is also on the player, but this movement state one is one that's really important, and it's not actually on the player because it's the template script. And I'll get to what that means in a second. But in this folder, we have the state script, so free and jump. Let's just add one new script called slide. Great. Let's open it up. When we're making a new movement state script, it's best to actually start by looking in the player movement state machine. Here we've got at the very top a giant comment that tells you A, how it works, but B, how to add a new movement state. It really is really easy. The first step is create a new class named movement state. So we create a new class named slide. Great, already done. So steps 2, 3, and 4 are all about changing the script that our slide movement state extends from. Instead of extending from mono behavior, we're going to extend from movement state. Okay, and so we can get rid of these mono behavior scripts. We automatically get a error. It says that we need to implement some inherited abstract members. So basically what this means is that movement state is some other script that requires that we implement these methods. So you can easily just right click here and show potential fixes. It'll give you the potential fix, which implements all the methods for you. But I personally find it a lot easier and more organized to just steal them from the free script. So I just highlight all of this and copy. I'm going to delete all of this and paste that. It's the same methods, it's in a better order, for me at least. So what do we actually want to put in all these methods? Well, we'll get to that in a second. There are a couple other setup things we have to do. So we just did step 2, which is make it not a mono behavior. Step 3, which is to delete the start and update methods. We don't need those. Step 4, we inherited the movement state class. And step 5, we have to make sure we're overriding those methods correctly. Step 6. This is the part that's really the important part. So we want to find all the places in the player movement state machine script with this to do with the asterisks and just do what it says in that comment. It's really easy. So there are 6 of them. Here's number 1. Create a variable to store your new movement state child script. So we can literally just copy this line and adjust it for our new movement state. We'll say hide inspector public slide. Boom. So we created a variable to hold the script. Now, down here, the second to do, we can copy this line again, change it to slide. So now we're getting the slide component that we just created the variable for. Okay, here we have to just call this method startup. So slide.startup. And we need to pass, it looks like this, and MoveRes or res And we're just going to do identically what the previous lines did. Here's the fourth one. Just call reset, so slide.reset. And down here at the very bottom, we have two to-dos. The first one is we have to add a new case to this switch case statement. So case move state dot our state is going to be sliding, and we can say return slide, just identical to what we just did there. Now you'll notice that there's an error on this. Well, that's because there is no move state sliding. So we need to add this, that's this last to do, add this type of state to the move state enum. Now that's over, and it reminds you in here, that's over in the movement state script. So let's open up the move state script, scroll all the way to the bottom, and it has the little to do there, and we can just add sliding. Great. Now, you might be wondering how we were able to call the methods like reset and startup if our slide script doesn't have any reset or startup methods. Well, that's because we're actually extending from the movement state script. And the movement state script has a bunch of code in it and implementation that basically handles all the behind the scenes stuff, so that all you have to do is put code into these methods, which are nicely named so that you know exactly what they're for, and the movement state script and the player movement state machine will handle calling all of them at the right times, which makes it super easy and very organized. Additionally, if you're working in a group on making multiple games over the course of a long time, using the same organizational structure is key so that you don't have to relearn somebody's style of making the code every single time. So this is a great way to organize for that purpose. Let's get back to it. Step 6 up here is done. We just did all the to-dos. Now we have to do step 7, add the script to the player game object. So let's just take slide, drag it on here, add it down at the end. Okay, and we'll actually want to make sure we're applying that to the prefab. Apply all. Great. And save. Step 7 is done. Okay, step 8. The new state has been added to the state machine. We can now implement the new state. What does that mean? So let's go into the slide script. Okay, before we get started, I'm just going to quickly add a couple variables at the top up here just to get us started. I've added the variables. So we've got a key to start sliding with, slide scale, that's how much to shrink the player model when we slide, a slide impulse, which is the force that we apply to the player right when we start sliding, the slide force, which is the force that we apply to the player continuously while they're sliding, the slide drag, which is the drag coefficient that we feel when we are sliding, and the min slide speed, which is the speed at which we stop sliding and just go back to the free state. So I made all these floats public so that we can change them in the editor. Now let's start running through these methods and figure out what they do. So on startup, basically just called during Unity's start. Nothing particularly special going on there. If you need to set up something, maybe you have if you're doing like a grapple component and you need to instantiate a rope or something, or just get a component, something like that, that would go in here. But we're not doing any of that, so we don't need to use that. Get my state. We're just going to go and fill these out as we go. So move state.sliding is the state of this script, sliding, right? So we want to make sure we return sliding. And other than that, you don't have to put anything else in there. Okay, then enter condition. So this is just the condition on which we enter the state. So we want to enter the state. If slide key is pressed, then we return true to enter the state. Now this will just automatically cancel any state that we are already in and immediately start sliding. Okay, so now allow AWSD movement. We're not going to allow AWSD movement while we are in the state. This one we literally just return the bool as to whether or not to turn on the AWSD movement script. On enter. So once the enter condition is met, we decide whether or not to use AWSD movement. And actually that might be better to put one line up. It's up to you though. That's kind of more of a setting. Oh, and we have to return false here as well. Return false. once we've entered, this onEnter method will get called. We get the previous state if we want to change what we do based on the previous state. When we enter the state, we want to add a force. So we'll say Rigidbody RB dot add force slide force times MoveRes dot orientation dot forward, and we'll do it in force mode dot impulse and semicolon. So great, but you might say, well, where the heck did all those references come from? What is RB? How do you know what MoveRes and orientation are? Well, because this class is a child of movement state has all these references in it. Movement state has a reference to the rigid body, to the player game object, to the movement state machine, to a script called movement resources. I'll get to that in a sec. It has access to whatever type of state that we are. It has access to whether the state is currently active. It has access to, and also the second since we've entered the state. So a lot of useful information is contained as a reference that we don't even have to refer to. Now this movement resources one is particularly helpful. It's basically a giant script with a ton of references to potentially useful scripts, game objects, and also methods to call to affect the player in certain ways. It also handles ground checking and a lot of that kind of stuff. So you can get the gravity script, for example, if you want to change the gravity. You can scale the player. We'll do that too. We need to scale the player and shrink him down. You could activate or deactivate AWSD movement. There are a couple resource methods to change the velocity, to kill noise, or to cap the velocity. We can apply drag. We can apply extra falling force. We can check what type of ground that we're hitting, the wall that we're hitting. There's a lot of resources in here, and if you want to add more for yourself, then feel free to, because it's a great place to put them, and it's a good way to keep it organized so that you don't have all your movement states doing the same thing again and again. So in this case, I called to RB, which is a reference in movement state, slide force, which is a variable we created, movement resources, which is that script that we were just looking at, dot orientation. So orientation is, so it's the way that the physics of the player is facing. The model might be facing in a different direction, but the physics of the player is oriented in a certain direction. So basically we can use this to say what we want to use as forward for when we apply forces, which is exactly what we used it for. We said orientation.forward, and we're applying a force in that direction. So if we wanted to, we could also shrink the player, maybe move resources dot scale y by slide scale. Oh, I said scale slides. Oh, now I can't type. Slide scale. There we go. And that's just going to scale it down by whatever we have slide scale set to. I know the scaling methods can get a bit funky, so feel free to change anything if you want to make it better with your player model or whatever. Okay, now WhileActive. This is going to get called every update that the state is active. And remember, there can only ever be one state active at a time. So this is what's going to be getting called whenever we're sliding. Okay, so this just applies a drag with the drag coefficient of slide drag in all directions of movement, and adds a force, a small force, to keep us moving a little bit while we're sliding. You'll also notice that I added this variable up here, slide direction, which will just store the direction of sliding when we started so that we'll stay locked in, applying the force in that direction as we slide. And I just noticed that this is supposed to be slide impulse, not slide force. So the exit condition is the condition on which we exit the state naturally. So if we're sliding and we get below a certain speed, there's no point in calling that state sliding anymore, and we'll just return to the free state. Return true to exit, otherwise return false, because we don't want to exit if that speed is higher. So then if the exit condition comes out true, this onExit method will get called. So all this is asking us to do is return a movement state, but we can also do any other things in this method as well. For example, when we exit the sliding state, we want to make sure that we set the scale back to normal, and we just want to return whatever state we want to switch to once the state ends. Free. So we'll just go back to free if the slide ends. So these two methods basically say if the magnitude of the velocity or if the speed drops below the min speed, then we want to exit, and when we exit, we want to scale the player back up to normal scale and go back to the free state. On reset isn't really important for this, but that just gets called whenever the entire state machine gets reset. Update child is a pretty useful method because the movement state class uses the update method. We need this method to be able to access the update method, the regular update, without overriding the movement state update. Now you'll note that this actually means that slide and all states, all movement states are actually monobehaviors. And yes, movement state does extend monobehavior. So you can call, in addition to all these methods, you can call any monobehavior method like on enable or whatever. Fixed update, another popular one. Then that leaves one left. That's on overridden. You'll notice that when we entered, we didn't check to see, maybe we're actually in another state, right? Maybe we're in free. Maybe we're jumping. Then there's a chance that we switch to jump without ever the exit condition being met. This means that on exit will never get called. But this method, on overridden, will get called. So we don't need to, return any sort of state because we're going to be transitioning to some other state, jumping in this case, where jumping overrides sliding. But it is important that we change the scale back to normal when we leave the state. So that kind of summarizes what all of these methods do. And we can see that we can put implementation really easily into these methods, and it's very well categorized. If somebody else who has not seen what you tried to do comes into this and wants to understand what you're trying to do in this state, they can easily read through all these different methods and know exactly how the state progresses. So let's just quickly test and see if our slide code works. Okay, here we go, running around, and I'll run close to something so you can see if it actually applies a force. But now let's go, pressing walk and control, boom, we get a slide. Looks great. And we stand back up when we're done. Yep. Okay, let's look at that in third person. Running, slide. Woo. Okay, that's awesome. Looks great. Wow, this is already shaping up to be a pretty awesome game. And we can watch that jump override the slide. Here we go. Jump, slide, jump. Oh, the jump's not overriding the slide. Okay, well, maybe we need to go and look in the jump code to see what the enter condition of jump is. Well, let's look. Jump script. It says the enter condition is if input.getKey down jump key, so that's going to be space, and state machine dot is in state free. So it looks like the requirement is it has to be in the state free, but maybe we want to make it move state dot sliding as well. That way you can override a slide into a jump. Great. Let's look in the third person again because I really like that. Okay, we're running. Now we try to slide and we can jump out of it. Awesome. Easy peasy. If you have, a ton of states, maybe the player controller with extra states had like maybe 8, right? That's already a lot to handle. It's well organized, but it's a lot to keep track of what all the enter conditions and exit conditions are. And if you get more than that, maybe 15 or even 20 states, that could be very complex. So it could be really useful to use some sort of spreadsheet-like organization. And I've found this useful to just keep my game structures organized and know what's going on, and particularly to communicate with my team what is the current state of the game. I'm going to do it for these here, but you can imagine you could do it with a ton more. And you can see that those methods make it really easy to organize what happens in each state. So let me just show you guys jump first. So here's jump. The enter condition is you have to be grounded, and we changed the state up in this video, but normally you just have to be in free. we allow AWSD movement in jump. On enter, we apply an upward force. While active, we do nothing and just wait until the exit condition, which is when we ground again. Then on exit, we do nothing and transfer to free. And on override, we also do nothing. For slide, which we just implemented, when control pressed and grounded, we could also choose some states that are required to be in. Whether or not we use the AWSD movement, we do not. We apply a force in the forward direction, scale the player. We apply drag and a small forward force. The exit condition, that's while we're active. The exit condition is if the speed is less than the min slide speed. When we exit or when we override, we unscale the player. And when we exit, we go to the free state. Free is a little bit weird. So the enter condition is never, because we never want to override another state to enter free. Maybe you want to change that, but for the default version, that made the most sense. Use AWSD movement, obviously yes. On enter, we do nothing. While active, we do nothing. The exit condition is we never manually exit the free state. Maybe that'll change for you if you have some sort of game where there's no real default state. You could even delete the free state if you wanted to. Finally, we've got the on exit, which is really irrelevant because we never exit, and on override we do nothing because there's no need to. So not only could you use this to kind of show what the current state of your game is, but you could also plan out your next thing. Maybe you want to add a grapple. You could plan out other states like this, so it all just makes it really easy to plan and organize your game. And so I just wanted to show you guys exactly how to use it so you can maximize your capacity while you're making your player movement. Good luck with your game design.